Hello. Hi.
Hi.
Okay, so in this tutorial, I'm going to cover some new things. So I'm going to introduce fluid engine, very basic, and then some basic mail scripting. So knowing this is totally optional for considering the entire course. May be useful, may not be useful, but just to have some inspiration for you guys. So yeah, so I'm going to cover these few things. So first, I'm going to introduce fluid engine and creating some 3D model really quick. And then I'm going to introduce some mail scripting basics, and then use this to generate some array of panels and create some rotations. And then using 2D fluid, and then connecting some mail script to make the 2D fluid information into geometry. And then connecting that with blend shape method, so create a panel array. And then I'm going to see if we have time. I'm going to introduce M particle and creating trail using two methods. One is using mesh to create a trail mesh. Another method is to use some little script and create particle trail and create them as nerves curves. All right. So let's begin. So fluid engine, I think they are quite interesting. I have used it for one of my, let me show you, for one of my design outcome. This project was made out of fluid engine. So you can create that. You can do this anywhere. You can do it in Houdini, Cinema 4D, I believe. And then what we did is we control this fluid in a certain way and freeze them at some point and use that as a 3D printed lamp design. So that was the project. So of course you can do anything you want. So I'm gonna show you how to set up that in general. So you can go to FX. FX, we have a lot of engine here. We have introduced enclose in one of my tutorial. We are going to deal with these two today. So fluids, there is 3-dimensional fluid and 2-dimensional fluid. They are exactly the same. It's just 3D or 2D. So if you see the options, there's this resolution and size, and there's this emitter. You can always change this later. So I'm going to just create a 3D container, and it looks like this. So this is the container. It's 10 by 10 resolution, and there's this emitter. And if you bring this up, this one start to emit this kind of a fog, yeah. So that is fluid engine, and if you want this to be more different and also orient in different orientation, we need to change that. So let's change the resolution first. So let's say 20 by 20, it changes the resolution, and we can also change the size of this if you want. Okay. Now you can find that there may be going a little bit slower. Yeah, so you can come in here, change different things. And you can also look at the emitter and you just select the emitter and change the positions of the emitter. So it goes to the Y up direction that recognizes that Y up is the gravity direction. Let's not bother. Let's just accept that. And that's like a smoke. It goes to the ceiling, isn't it? So let's just look at it. In emitter, in fluid engine, only thing you can actually control this thing is not the emitting direction, but the environment forces. So that's why if you want to change the force of their movement, particle movement, you need to add some forces. So in order to do that, you need to go to fields, and you can create all of these different forces here. So for example, let me try this vortex. And if I have vortex there, it starts to create vortex force there. So obviously you can go into the parameters and change things around to create that kind of vortex force. Yeah, it's obvious. Yeah. And then you can also use Newton that creates some kind of gravity. So it
pieces are in ZBrush in terms.
So it's kind of dragging the force. So if you don't like the original gravity, you can also work with that, so on and so forth. Anyways, there's also, you can also add another emitter by adding fluid, add, no, where is the add emitter? So you click on the fluid and add a emitter. So you can have now two emitters in this force field. So let's say this one, the vortex is a bit too strong, and you can always make the magnitude down. Okay, I think this one it's just an example. So you can like play around with this to create interesting fluid shape. And okay, so let's say I'm not so sure. And if you have more resolution, obviously, in different environment, it does different things. You can also add obstacle. For example, if you have something like that there, let's make things avoid this guy. So in order to do that, we need to go to so and constraint. No, enclose and create passive collider. So I believe this will make it to avoid this. Let me check. That happened. No. Let me see. Where is the constraint? Fluid. Make collide. Okay, anyways, I will figure that out later. So I think that was not correct. this didn't become the passive collider. Correct. Okay, anyways, you can add a obstacle. Yeah, I'll figure that out. But let's not waste our time. So now if you want to make this into a geometry, it's really easy. You can go to modify, convert, and end particle, fluid to polygon. So if you say that and you run this again, it starts to change the particle to this, but right now the resolution and everything is not enough. So you can also change those settings. So you can keep on changing this, of course, but we can go to the end fluid. And there's this out push mesh. You can change this to quad mesh or different methods, but the cleanest one is either triangle mesh or quad mesh. And you can also change the mesh resolution and mesh smoothness and so on. And the previous so right now it only grabs the really thick white area. So I think we just have to reduce the resolution. So let me try to even reduce this resolution even more. Just become a little bit more like bulky. Yeah, but right now it's like constrained with the box quite a lot. So, but anyways, I think if you want to really play with this, you can just work with it. Now, if you just copy it out and if you just apply some more smoothness, or you can use ZBrush to add some details and whatever you want, you can play with this. Yeah, so that's how I wanted to introduce what fluid system is, but there is also this thing called M particle, and there are like slightly different and serves slightly different purpose. Yeah, but M particle doesn't have to be constrained within a world boundary, while fluid has this boundary of world. Right, so that's something different. So let's, there are different purposes, so you can pick and choose whatever you want to work with. So I'm going to move on to the next exercise. So I'm going to come back to the fluid in a bit, but let's dive into a quick Mel scripting. So Mel scripting is really helpful if you are a long time Maya modeler. You will find it really handy. So you'll see this script editor by clicking on this icon here, and you will see a window like this. So you won't have anything, or you will have something, but don't worry. So for example, whatever is happening in Maya is actually a Mel script. So for example, let's create a cube. Do you see that all of the processes are actually a Mel command? So this is the result. And now I selected a cube. And if I deselect it, it says selection cleared. If I select it, it says selected. And then if I delete it, it says it deleted. So it's really straightforward. So if I just copy these lines, Control C and Control V here, and just select them and Control Enter, it repeats the comment. Yeah, so if you want to keep on repeating something, this is a really good method, and you don't have to really learn how to script it, because you try something here and see what it says, because all the commands are written here. And you will now see, okay, you can already guess, okay, maybe this is not that straightforward, but you can see that, okay, this must mean width, height, and depth, right? So I can actually change this number as I want. So I'm gonna make it 5, 4, and 3, for example. And I'm going to, I'm gonna delete this one, and I'm gonna try this again, Control Enter. So now I have a cube that, oops, that has a 5, 4, 3 parameters in it. And how do I find out more detail? You can right click here and go to a quick help. Sometimes it doesn't work. The safest way to do it is to go to help and find help on selected command. So if you want to look at this help, so you select it and help on selected command, and sometimes it's not really directly linked. And all the error message is coming here as well. So it says error. This help file is not, it's not found. It's okay. We can go to mail command reference, and it goes to this website. And you can just copy this link and use your preferred browser and just save this link somewhere, and you can always just refer to this. So for example, if you are curious about how do I make a polycube, and you can search for a polycube and look for the commands. And let's have a look. What does it say? So, okay, it said CH. What does it mean? So CH, it's long. So it says polycube. CH, okay, CH is construction history. So that normally we don't really use that, okay, good to know. We also had O, that is object is on, and we had also AX, that is axis. So you can find all of these comments by coming in here, and actually you can skip all of this and just use whatever you need. So for example, I know that now you have depth, height, and width. But how do you know, how do you abbreviate this like that? So you can see under here, you can see how you can abbreviate these constructors over there as a simpler characters like that. Okay, so But we don't really need to like always come back here and reference it. We always can just try to make something here. Okay, and just use this comment here, comment line here. So in order to make a polygon cylinder, I see I can use this, and probably like all of these are not really necessary. And axis, okay, I can leave the axis, and I need a radius, height, and scale. And let's check what this CUV is. So create UVs. Okay, so 0 means no UV, no normalization, whatever. And the 4 was normalization. Okay, so we don't really have to texture it or something, so we can just ignore this for now. So yeah, so now you can like really clarify what parameters you need, and you can just write this down and keep on creating the ones that you require. See? Yeah. So that's really handy to understand how this works as a Mel script and how you can just quickly refer to the command helper. All right, so that's really easy. And let's try to make more benefit more from the use of Mel script. Okay. So in any scripting language, you can define a object, and so there are a few things that you want to know, which are the data types. So yeah, data types. Doesn't have a list of that, it's okay. Go back to that. Doesn't want to go back. Okay. Let me search Mel data type list. Variables in Mel. Somebody made a list. Okay. So this is very common for any scripting language. So any language, so for example, C#, let's go search C# data type list. And always different language has very similar data type, list of datas. Like these are the common data type list. And it's same as Mel. The most commonly used is int, so which means integer. Integer is a number that doesn't have decimal number. And another one we use is float, which is a number with decimal number. Another one we use very much is Boolean, which is true, false value. And then another type is string. String is like a text. So any text is a string. So you remember integer, float, and string, and Boolean. That are the data type that we use very often. And we also have vector in Mel script. So let's see how we can use them. So for example, if we are to use an integer, I told you, so whatever we are not going to use as a calculation, you can always comment it out like this. So if you just add 2/, it doesn't calculate. Okay, so for example, if we have an integer, we want to call it, we always have to use a dollar sign. Dollar sign like that. Yeah. And we can say Okay, so I can say number A. So this is a number A. And I can say declare something called number B. This is called declaring a number object. Declare an object. Declare an object. So declaring an object called number A that is a integer. So that's what this means. And then what you need to do is assign a number to this A. So A can be a 5, for example. And number B can be a 9, for example. So these two lines is called assign value to the object. So you always have to have a declaration and assignment for any object, all right? And you can do this in the same line. For example, you can do declare a number C is a 12. You can do declaration and assignment in same line. So that's how you declare and assign, okay? And you can make an operation. So declaration can only happen in once. And then you can use a print to print some command here. So let me clean this. And what you can do is you can print number A on this line. So in order to run this, you need to select all these lines and control enter. Yeah, so they understood your command and then you asked to print. So it printed number 8. So that's a result. Okay, let's see what we can do with this. So let's declare a number, another number, say number D is number A plus maybe number C. You have to use the $sign. You have to always have to close with a parenthesis. And then you can print number D. And let's see what it does. So you have already run these lines, so you don't have to run it again. So you only need to run this line, control enter. And you need to run this line, control enter. So you asked to print number D and it printed number 17. And before it printed number A like that, it's because I didn't add the $sign. So that's the difference. All right, so that's the print command, and that's how you make some number operation. All right, so there is a very simple operation that you want to remember, which is plus plus and minus minus, something like that. So I'm going to declare a number called X. I'm going to declare this as an X. Control L, control enter, and now computer knows that X is 0. Okay, now if I say X is plus 1, and if I now print X, what should it print? It will print X as 1, right? So if I run this again, it's gonna print 2. So in Mel, it runs like this. It only runs when you run each line of the command. So instead of writing it like this, you can also write it like this. So x plus plus. X plus plus means x is x plus 1. Let's see if this increases. Yes. Okay, x minus minus meaning x is my x minus 1. Okay. So that's very well used. So you just want to remember this is for any scripting language. So plus, it says x is plus equals to some number. It means x is x plus 5. See, it increases by 5. And also if it says minus equals to some number, it means it decreases by 2. Okay, so that's about different operation commands. All right, so what is the difference between float and integer? So float is a number that you can declare a decimal number like that. If we say int and a number, and if we give a decimal number, this is not going to work. This is returning a integer. So Mel is pretty good enough so it doesn't error, but it just gives you the number. But also it means you might miss the mistake in some of your future projects. So don't make that mistake. Okay, so how about vector? So vector is a number that you have 3 different number coordinates. Vector 1. In order to declare and assign a vector, you need to use this sign. So you can use 3 different float to declare. Let's say 0, 0, 6.7. So and semicolon. So that is a vector. A vector will appear like that. And vector can do mathematics, same as any other number. So if you add a vector like this and print vector 1 plus vector 2, it doesn't print operation. Vector 2 is an undeclared variable. Oh, I see. I didn't run this line. Okay. So yeah, so you can run an operational vector like that. Okay, vector can return also a magnitude, which is the length. So you can also print a magnitude of vector 1. It should be 6.7, which is the length of the vector. Magnitude, yeah, so we need to use this sign like this. Yes, so this is pretty seems pretty weird, but this one is not a is not this, it's not this, is this. This one is actually in the keyboard is this thing, is this one. It's not this, it's not this, and it's this thing. So yeah, so that means it's when you're referring to a Mel script to run a command inside a string, then you have to use this sign in Mel. Okay, we covered magnitude. Okay, we can also Okay, we can also do sort of different things. We also have string. Okay, what is string? String is a word. String 1 is a word like hello. That's a string. So if you print this, you enter, yeah, it prints hello. Okay. All right, so bear in mind, yeah, after a few steps, we can do something more interesting. All right, so how do you make a group of things like an array? So for let's say for integer, we can create a integer array. And then you have to use this to open up possibilities to add multiple numbers inside. So it's integer. I'm gonna randomly put some integer in there. Yeah. And then I'm going to use print to check the size of this array. So I'm going to say size of this array and please print it. So it says it's a syntax error. So size of the array. Let me just check this line. Okay, size of the array. This is wrong. Let me just print this. Print. So I have this declared this and the result is this many numbers. I printed. Okay, now it can print this many numbers. That's great. And let's see what is the size of this array. Can we check the size of this array now? Okay, now the size of this array is 7. So now we can also print this size of this array. Let's see. Yes. So we can also clear an array. So you clear the array now. If I print that again, the size is 0. So that's about array. So this was about string. So these were all about data types. Data types. Okay, that's about operation and data. Okay. Cool. So we went through array, of course, float array and string array, vector array. They're all similar, but let's cover vector array now. Vector can also be an array. Vector array. We can store few vectors within a array. So for that, we can have vector for example. You can of course have more. Okay, let's run this so it recognizes. Okay, it has this many vectors. Let's try to check the size of it. Size of the vector array should be 4. Okay, nice. And what if you just want to print the second array, second vector? So for that, we can return something like this. So we can return, this is the zeros, first and second and fourth, third. So if we put 1, it's going to give us this. So let's see. So now it returns the second vector for us. Yeah, so that was about array. And okay, so maybe just last few concepts and then we can go to an example. Yeah, let's go directly to the for loop. So for loop is something that you can do many things for as a repetition. So what if, okay, what if you have a, okay, so I'm gonna just go ahead and write the for loop. So for loop I is smaller than 5, I plus plus. So don't worry too much about this line. So this is a basic syntax for loop. What this does is it does repeat for 5 times. And it's going to start from 0 and increase by 1 every time until it hits 5. So if you want to repeat hundreds of times, it just changes to 100. Yeah. So for this, for example, if I print SCI, so if I just control enter and do this, it repeatedly print the I becomes 0, 1, 2, 3, 4, right? So what if I make a box, for example, and let's copy the line for making a box here. So that's polycube. So instead of just printing the I, what if I use, I don't need this information. What is this axis? Okay, anyways, let's use this information. So I'm gonna make 1 by 1 by 1 box. Okay, and if I do this for 5 times, what happens? So it creates a new 5 geometries here for me, but in same position. So let's use this I to help us to change our position. So how do we do that? So there is this command. So I'm going to just click on this one and I'm gonna see what happens here. So I'm gonna see if I change this to 5. So it says that set attribute and the translate X becomes 5. So that is something we can directly use here. So whenever we create a cube, we are going to use set attribute. And yeah, so there is, it's just in my note, there is this command, but I want to show you how and where to find it. So let's go back to the help command, Mel help command. Yes, and then let's go to polycube. Polycube command. Okay. Oh, set attribute command. Set attribute. Let's copy. Exactly. Set attribute command. Yes. And there are a lot of attributes that we can add, obviously. There are like a lot of these things, yeah. So let's see where I can find that. Okay, anyways, so for here, we can actually see that polycube 1 translate x, and we can set a number 5 there. And we can set for y, we can set it there. And we can set something like this, right? So we can learn that aspect and then say, actually there is a much easier way, but let's see if this works. And say 5. So I'm going to create a polycube. Let's delete these ones. Let's create a polycube and set the translate x. Translate x. Just want to avoid this cube x thing. Does this work maybe? So that also doesn't work. Okay, in my note, it says if I say t, I can change with 3 values. So let's say 0, 0. So dot t is the dot transform of the selected geometry, and you can just set the position. And if you want to change the rotation, you can use dot r. So let's say 1, 1, 0, for example. So it starts to apply some rotation. If you see that actually changed the rotation. So it applies to the rotation. And you can also set attribute for scale. So let's say 2, 5, 1. So you can apply the scale. So these are the transform, and the translate and rotation and scale can be applied like this, which is really handy. All right, so for that, we can actually then use a way to just make some array or using this loop, right? So for now, I'm going to just use t and use my number I instead of a number. I'm going to use the I that is increasing over time. So I can create a array of box that has this rotation. Okay, which is interesting. So let's change the height. Sorry, so the height of this. Okay, the size of this guy, which is what? Let me check. Just the depth, yeah. So depth, I'm gonna make it to 0.5, 0.2. Okay, I'm going to recreate this. Okay, I shouldn't have these ones. Okay, all right, I created a panel. Let me just give them a little bit of interval, like 0.1, for example. Plus, maybe this was not allowed. Okay. So I see. So, okay, it got moved, but okay, so I should have copied, I should have timed this to 1.1 instead of just adding them. Okay, so I just wanted to add some interval so they have some more room in between. Okay, so I can try to make this into maybe 25 of them instead. Okay, and what if I want to make all of this to be copied like this many times? So I need to times all of this that many times, right? So what if I want to copy all of this maybe another 25 times? So in order to do that, we need to nest this loop. So for that, we are going to copy this line, say J, use J instead of I, and loop this inside. So I'm going to use tab to move all of this line inwards. Yeah. So I'm doing this 25 times, and then doing this another 25 times. So, and then I'm going to use this J to increase my Y position. Let's see, times 1.1. Let's see what syntax error. So it says line, something syntax error. So I'm going to check J. Oh, I didn't add this parenthesis, of course. So you need to close it well. Yeah, now you have all of those panels for 25 times, 25 times. Okay. And I'm going to also name each of them correctly using this information. So I'm going to declare a name, say string s name. So name of the panel will be panel plus I and plus J. So this is just to store all of this, and we can actually get return that later. So for that, when we are creating them, we just say n and declare their name. So once we do that, let's just reduce the number a bit. So make them into 10 by 10. And Control X. Now you will see that their name is more, their name is more like related to their number and ID. Okay. All right. So now we can actually do something. So we can change their rotation or their arrangement, not by creating them every time, but by just selecting them every time. So we are still going to use this for loop, but instead of creating them every time, we are just going to use their name to make the selection. So in order to do that, we need to get this name again. The name is set over there, so we know exactly which name we want to select. And then you use this name to select the panels. And then you will set attribute. You can set the attribute of their rotation, .r. And let's use I and j to affect their position, their rotation. So, okay, so now I'm going to run this once. Okay. And now I'm going to just run this line to affect their rotation. So if I want to change their ways of being rotated, I can also like add a number, just affect their rotation amount. You can also, of course, add also the attribute on the scale. Scale. You can also use the, let's see, could be interesting. But the scale, maybe let's use the scale to affect the Z direction. The default scale should be 1, otherwise it disappears. So like that. That's interesting. You can play around with it. Yeah. So of course you can add more resolution on both ends. I'm going to delete all of these and create the panels again. And apply this to a larger group. Yeah, which if this is weird, I'm going to set attribute just as 1, 1, 1. And do this again. So however you want to have this affected. Why is that like that? Something weird happening over there. Okay. Yeah. Anyways, yeah. So that's the principle. You create a panel and you select, make changes. I wonder what's happening over there. Okay, but let's just leave it there. Okay, so at this point, do you have any question?